Hello, guys. Welcome to another episode of CUDA Education. Today, I want to do a relatively quick video on normals and computing normals. In computer graphics, computing normals is a very important thing you have to do. It is especially important in reflections, mirrored objects and reflections and things of that sort. It is important for lighting, for graphical realism. Um, if you want to add any textual nuance to a surface, for example, a brick wall. If you actually want to have the bricks extruded or receded, or get a visual effect of that on the brick wall instead of the wall just being looking like a flat like wallpaper with pictures of bricks on it. You actually want to be able to visually see um grooves between the bricks and all that stuff. That is done, that realism that is done by tinkering with the normal for the surface and things of that nature, right? So um obviously, for in our case where we're doing reflections, rays hit a mirrored surface like this, and it has to be reflected correctly so that the mirrored surface and our application and what we're seeing looks realistic and true, and it and believable, right? So that's the importance of normals in computer graphics. I don't, I have the link to a video that sort of gets into more details about normals in computer graphics. And actually, it shows the brick example I'm talking about. So it's a very cool video. I would link it down below um, in the description. But what I wanted to do today is play around. We have our reflections application that we've been working on for a while, but now I want to play around with this normal calculation, right? So my goal is to basically tinker with the normal calculation so that we could visually see what happens when we change the normal. And then there will be other considerations. Before we do that, though, first of all, you guys, if you want to have these applications running on your machine, you need to get tutorial number 1 to install the Vulkan API on your Windows-based machine with a Vulkan-capable GPU. You need to install tutorial number 15 to get tutorial number 15, because that's where the examples are. All these Vulkan examples, including this application, it's a list of examples that you have, and it's a great way to run. It's a great way to learn Vulkan. Now, if you want to run the ray tracing example, this is a ray tracing example. You need to make sure your GPU is also ray tracing capable. So yeah, if you want to be able to run these examples, you have to make sure your GPU is Vulkan capable and also ray tracing capable. All right, so we can kind of see that we have a light source that's bouncing around. Um, we see reflections on the spheres, and of course we see a mirrored mirrored reflection on the teapot, right? Um, it's important to really look at this scene and just understand, what's going on, right? So it's fairly obvious. We've done it in previous things, but what we're gonna attempt to do is we're gonna attempt to for the reflected rays, right, on the mirror, we're gonna attempt to change the normal and see how it affects the scene, right? And this will give you an idea of how uh, the normal in computer graphics is affects everything that we see. Um, so let's just do that. So the the thing that's responsible for the reflections is the hit shader, right? So the hit shader, as we've kind of investigated previously, the hit shader is what sort of records hits and then also, deals with reflections and all that stuff. So if we want to change the normal on the reflections and have it bounce around and be sort of inaccurate, if you will, um, or move, we have to change the hit shader. So that's exactly what we are going to do. So we update the hit shader, and then of course, as you guys know, we always have to recompile the shader. So the shader is a separate file in our example. Um, so these guys here, right? So the closest hit shader, right? So we're updating the shader file, and then we have to recompile the shader um, so that it's into spare V format, and the application can read what changes are made and what's going on. Um, so let's do that now. So let's rerun the application, and we now get this. Um, as you can see, the normal of the reflections is it's sort of following the light. So the light source is moving, and the normal for the reflections is also moving with it, right? Um, we could see that we're having reflections here, and we could see a bunch of stuff going on here, right? Um, Normally, this black stuff has something to do with, it's a reflection of the reflection of the reflection, and of course, we only do four reflections deep, right? So that's why we kind of see this black stuff, when it moves around. But this is when we change the normal for um, or the normal vector in our computer graphics application. Now, really and truly, we should see an effect with the solid colored spheres. These spheres are not procedurally generated, so um, it's not done like in the ray tracing intersection application that we discussed previously. This is sort of a mesh, but there are other considerations as to why we don't see an effect on the solid color stuff. Um, but for right now, we're just focused on the um, changing the normal on the reflected rays. So as you can see, guys, so if we turn around, we also see some stuff, right? So I don't want to dwell too much on this, but just to show you that when you change the normal, you have control over, and of course we're not really seeing the light source because we're on the backside of the light source. But when you change the normal, um, it's all calculated, right? And it's the closest hit shader that does it. Um, basically what we do is in the hit shader we modify the normal calculation to we modify the normal calculation to kind of skew the normal and follow the light source, right? We can do we could make it more violent. I'm just recompiling the shader now, but all of this stuff is controlled, with Vulkan, right? Vulkan gives you a lot of control over a lot of things, right? So it's a very low level language, which is why it takes a lot of scripting and stuff to get things done. But the benefit of that is that you have more control over everything that happens, right? So let's now rerun our application, and you could see you could see it being a lot more violent, right? Um, I know this stuff goes crazy, but anyway, just wanted to show you guys. As I said, I have a video below. I'll link a video below that discusses the normal in more detail and why it's important. I think it uses Blender as an example. So we'll continue to investigate this stuff. But understand that it's a hit shader that's responsible for all of this, right? It's a hit shader that we modify. That's the only modification we make. And then if we simply go back to the original file, we will see that everything goes back to normal. Yeah, guys. So just continuing our journey on understanding computer graphics and understanding the Vulkan API. Nothing too. So we're back to normal, right? Our light source is bouncing around, but the normal now isn't following. It isn't following the light source, or it isn't changing as a result of the light source, right? It's just calculating the normal as it should, and we're seeing the reflection correctly. There's no bouncing around of anything. All right. All right, guys. Thanks for watching. As I said, I wanted this to be a quick video, so we're at about 13 minutes. I think that's a good look. Again, guys, tutorial number 1, tutorial number 15. You could also get the whole tutorial series. Get you up and running with Vulkan. Make sure you have a Vulkan-capable GPU on your Windows system. And make sure it's ray tracing capable if you want to run the ray tracing examples. All right, guys. Have a good day.